What's up, everyone? And welcome to the 32nd episode of Superbrain Radio, the second installment of Chapter 7, Misfiring, where I'm kind of honing in on key areas of neurology that can pretty much go sideways if you have the right or wrong chronic biological habits ensuing, if maybe some type of supplemental bias being input into your system is interfering with your ability to make assessments on quality of life and health, so on and so forth. All of these things that fall under the term of allostasis, which we've talked about in the past, is the majority of our body's ability to adapt and has to do with things that more have to do with performance and quality of life and less about mortality and the prevention of mortality. So, things that can go allostatically sideways in neurology is what this chapter is most specifically about. And we talked about the hypothalamus at first, which is different than what I would have done in the past. I used to start with the vagus nerve, which is what we're talking about today. But I believe that when you hear me describe the vagus nerve's function more as system-wide bias, it'll make you understand its importance more so than when you see something like the hypothalamus. You're just outright impressed with the bandwidth of intervention capabilities, things it controls, so on and so forth, that are all directly under its control, really. Anything nutrition related or metabolism related, you can pretty much attribute to the hypothalamus. But when we talk now about the vagus nerve and how it imposes this system-wide bias, we immediately start to see that although there's maybe not a long list of bullet points under its direct control, the amount of bullet points, if you will, under its indirect control or secondary tertiary action based control, like we talk about in chess like analogies all the time, it's absolutely massive. So we can ultimately, and in this reductionist manner, start talking about the vagus nerve as the biased decision-making confines for the rest of biology. Our autonomic nervous system is where this cranial nerve is going to exude its function. And what that means is it's going to have to do with things that happen on their own. The key allostatic employees and players that are allowing things to function on a daily basis. This does not necessarily have to do with conscious, meditative, or intimate phenomenological control. What's interesting, to digress my point, is that the vagus nerve does have some sense of social and hippocampal and memory based input with its decisions. So when we talk about the two portions of the vagus nerve that you can kind of slip into, these are going to be based on past experiences, success and social feedback ratios in regards to what happened last time you chose these behavioral decisions, so on and so forth. And again, let me remind you that this is under secondary action, meaning the vagus nerve is not directly allowing your amygdala to turn on so that you can go ahead and make anger or nefarious based decisions, but by the vagus nerve lacking intervention and the amygdala getting red hot now, it's set up the opportunity for that to happen. When your vagus nerve is firing, the amygdala can't also be red hot. Maybe it can simmer a little bit, but it can't get red hot. And all of this is going to come to start making much more complete understanding and pictures in your head in a moment. When our vagus nerve turns on, it exudes what we call tone. It's a rigid activation of the nerve, and it's actually the longest cranial nerve in our body. It's essentially going from the center of your skull down to your stomach. It's huge. So, when this turns on, we are now going to have increased blood flow to the stomach, the lungs, and the heart. This increased blood flow is going to decrease the need for activity because blood drives things. Oxygen, nourishment, ions, things that are almost free in their manner of allowing things to turn on. This pulls blood away from what we call working tissue. So things that allow you to move and function. Not completely, but it's going to be a bias. So what goes along with this toned, what we call parasympathetic activation, it's the parasympathetic branch of the vagus nerve, is going to be this relaxed environment we were just talking about with more blood in this area. What this is also going to encompass, like I briefly alluded to, is the higher likelihood to choose decisions that promote safety. Now, what that means is it's lacking exposure to danger. There's an inherent difference when I talk about the other side of the branch in a moment. So, choosing behaviors that promote safety and avoiding danger are like choosing to sit on the couch and watch TV instead of going for a run late at night when you live in a city. Now, this is also going to go along with choosing things that promote safety, again in a biological sense now, so different types of decisions. This is going to promote fat usage in the liver. This is potentially going to promote appetite in most people, so on and so forth. So it's kind of like drawing a line in the sand and saying anything that has to do with our opportunity to heal is going to happen in this parasympathetic branch. Now, when the vagus nerve loses its tone, deactivates electrically, and loses that rigid exposure, which drives blood, we're going to see blood go to the working tissue, we're going to see blood rush to the brain, and we're going to see the heart rate increase rapidly. What this is going to do is turn on the sympathetic branch of the vagus nerve and the autonomic nervous system, which is mainstream known as the fight or flight system, but in reality, I don't think that's quite accurate. What I would say is it's the response to potential danger. Very, very different when we start to dive into what that means. So responding to potential danger is different than promoting safety, because for some reason we've recognized that there is the existence of some type of danger in the first place. Whether that danger is a viral bacterial load altering DNA in your system, or it's a bear right in front of you drooling and growling. It's ultimately the same biological decision, which is very important to understand as to why maybe the fight or flight concept isn't the best analogy and way for us to initially gain exposure to this. What this is also doing is choosing behaviors that continue the sympathetic nervous system. Meaning, when your amygdala turns on, when your hypothalamus alters, when all these things happen, they tend to select behavioral decisions via the motor cortex and the frontal cortex that go together and choose more dopamine, more norepinephrine, more excitement, etc., until that somewhere in biology, usually our liver or our muscle cells or whatever it may be, cardiac rate as well would be included, can no longer keep up. And then the vagus nerve will start to tick in. It will slowly increase its tone, slowly increase oxygen rates, slowly alter your perception and your decision-making process to come back to that parasympathetic side. And that's really why we talk about it as system-wide bias. It's not inherently doing very, very much, but it's altering to a small or large degree exactly what's happening everywhere else. And if you were looking for some type of specific parameter, zero vagal intervention is a heart rate of 100 BPMs. Anything technically below 100, even 99, is at least 1% the vagus nerve is still hanging on. Anything beyond that, you are now distancing yourself from vagal activation, which means you now need to decrease all the way to 100 to get to 0 and then go back. Similar to a thermometer that can measure negatives and high heat-based temperatures. So, what this means to you all is that it's important to have biology that can handle both sides of the vagus nerve relative to you and your life. And if I had to succinctly say it, as I've spoken about health publicly in the past, this is health right here, everyone. The synergy between what your biology can handle and what you expose yourself to is health. You also need to understand that your phenomenological, emotional, and perceptual definitions of safety, success, danger, relaxed, excited, happy, sad, nervous, anxious, etc., are all going to be slightly different for the most part than the vagus nerve's definitions. And what you should try to do, and what mindfulness is a plight for, is to shrink the distance between those two decision-making processes and definitions so that you can inherently see why your vagus nerve is not allowing your heart rate to spike when you're exhausted, even if it's midday and you have to go to work. There's reasoning behind everything, and if you can see it and allow your decision-making and definition process to meet in the middle, you're going to actually have a higher likelihood of success and control over your own body, biology, and mind. Lastly, the vagus nerve is not the president. Its decisions can be vetoed if there's not proper support through enzymes, hormones, biology, ability to handle blood movement, cellular action, pH, all of these things. So, you can actually be falling asleep with minimal vagus nerve intervention because of our circadian rhythm and the response to nighttime. But the vagus nerve isn't as turned on as it should be to allow you to have restful sleep. This can also involve appetite and so many other things. But ultimately, understanding the vagus nerve is a plight for a little bit of philosophy and a little bit of mindfulness, and looking at the why behind what you may be feeling.